The aim of practical to perform the Morse test on IC engine. Here the schematic diagram of Morse test. The purpose of Morse test is to obtain the approximate indicated power of multi-cylinder engine. It consists of the running the engine against the dynamometer at particular speed, cutting out the firing of each cylinder in turn and noting the fall in brake power each time, while maintaining the speed constant when one cylinder is cut off. Power developed is reduced and speed of engine is fall. Accordingly, the load on the dynamometer adjusts so as to restore the engine speed. This is done to maintain the friction power constant, which is considered to be independent of the load and proportional to the engine speed. To observe difference brake power between all cylinder firing and with one cylinder cutoff is the IP of the cutoff all cylinder, and last summation of the all cylinder of IP would then give the total IP of the engine under the test. Here engine shaft means the crankshaft connected to dynamometer for the measuring the brake power, cutoff switch for the short circuit of cylinder. Is our the practical setup or the test rig for the multi-cylinder engine testing. In the test rig, you can see that here for the power measurement, voltage and ampere, and given the brake power. Here give the RPM, and this is our the multi-cylinder engine. For the engine starting, we require start switch. For the cylinder cutoff, we will require first cylinder cutoff switch, second cylinder cutoff switch, third cylinder cutoff switch, fourth cylinder cutoff switch. For the load applying is load bank, and for the increasing or decreasing the speed, accelerators are given. Here the dynamometer for measuring the brake power, crankshaft is connected with the dynamometer. For the initial starting, for the spark plug or the cutoff switch, we will require the battery supply to the power. Before the starting the experiment, first check the fuel supply, lubrication oil, availability of the cooling waters. First set the dynamometer zero load, running the engine till it attains the working temperature and steady. Adjust the dynamometer load to obtain the desired engine speed. Record this engine speed and dynamometer reading for the calculation of the brake power. Now first cylinder is cut off. Short circuiting a spark plug can do this, reduce the dynamometer load so as to restore the engine speed by the help of the accelerator. Record the dynamometer reading and for the brake power calculation. Connect the cutoff cylinder and run the engine on all cylinders for short time. This is necessary for the steady state condition. Repeat the step for the cut off the all cylinder like second cylinder cutoff, third cylinder cutoff, and fourth cylinder cutoff, and some necessary calculation like the first indicator power is the total BP when all cylinders are running minus when first cylinder are cut off we get the brake power. Same for the second cylinder indicator power is the total brake power. Subtract the brake power when the second cylinder are cut off. Same for 3 and 4. Total indicated power is equal to indicated power 1 plus indicated power 2, indicated power 3 and indicated power 4. We get the friction power is the indicated power minus the total brake power. Mechanical efficiency is the brake power upon the indicated power. Here, when all cylinders are running, we observe the brake power is 7.5 kilowatt and the speed is the 1300 rpm. When first cylinder are cut off, we observe the brake power is 4.75 kilowatt and speed is 1290 rpm. When the first cylinder are cut off, the speed are reduced. For the maintaining the constant speed, we have a operate the accelerated condition for the obtaining the previous speed. Same for the second cut-off cylinder, we get the brake power 4.0 kilowatt and the speed is 1280 rpm. And third cylinder cut-off, we get the brake power 4.5 kilowatt and speed is 1280 rpm. When the fourth cylinder are cut off, brake power is 4.8 kilowatt and speed is 1290 rpm. After the experiment, the observed table here brake power, engine speed and cylinder cutoff. When all cylinders are running, our brake power is 7.5 kilowatt and engine speed is 1300 rpm. When first cylinder are cut off, the brake power is 4.75 kilowatt and engine speed is 1290 rpm. When second cylinder are cut off, we get the brake power is 4.6 kilowatt and the engine speed is 1280 rpm. When the third condition, when the cylinder cutoff is 3, third brake power 4.5 kilowatt and the engine speed is 1285 rpm. And fourth cylinder off, we have a 4.8 brake power and the 1290 engine speed. So here we obtaining the constant rpm. Calculation for the indicator power of this cylinder is IP1 is 7.5 minus 4.75, 2.75 kilowatt. Same for the indicator power 2, 2.90 kilowatt. Same for the indicator power 3, 3 kilowatt. And for the indicator power 4, 2.70 kilowatt. Total indicator power is the summation of the first indicator power, second indicator power, third indicator power and fourth indicator power is 11.35 kilowatt. And our friction power is the total indicator power subtraction of the total brake power means the when all cylinders are running we get the 3.85 kilowatt friction power and our we have achieved the mechanical efficiency is 6.07%. Thank you.